All right, 9, 10, 11, and 12 are asking us to answer either true or false to the statements. So let's take them one at a time. Number 1, two planes can intersect in exactly one point. That goes back to the problem that we just looked at, the problem where we had plane P and plane... The one where we had plane P and plane S, and it looked like they intersected at point X. It looks something like this, with point X down there. And we said even though it looked like they were intersecting at point X, the answer is actually false, because they always intersect in a line. And if that said line in one line, this would be a true statement. All right, next question. When a line lies in a plane, every point on the line lies in the plane. So let's look at it. If we draw a little picture and we say, okay, here's a plane, here's our quadrilateral, here's a line, right, that's in the quadrilateral, it's lying in there. And all of these points that make up the line, they are in the plane as well. And that's actually true. That will always happen. It's impossible. Even if we extend it off of the plane, right, since all these other points are in it and the plane keeps going in all directions, all of the new points on the line will be on the plane as well. All right, question number 11. If point A and line J both lie in a plane P, then point A must lie on the line J. Let's look at this. So what they're saying is we have plane P, right, plane P, and they're saying A and a line, point A and a line, both lie in the plane. Okay, so I can draw a line, line J, and the question is, when I put point A in the plane, do I have to put it on the line? Well, you could put it on the line. We could put point A here, but I could just as easily put point A here, and it will never be on that line. So this is false. They do not have to lie on the line. They can, but they don't have to. All right, last question. Two intersecting lines can have 2 points in common. Well, let's look at them. If I have a line, let's use my line tool. I have a line, and I have another line, and they intersect right here. We have exactly 1 point of intersection right there. Since lines are straight, there's no way for this line to bend back around and touch it again. So there's only 2 options here. They can either intersect exactly 1 point, or they can intersect at every single point if they just are the same line. So the answer to this one is also false. They cannot have 2 points in common. They either have 1 or all points in common. Or they could possibly never intersect, which is a whole different world altogether. All right, moving on to 13. This is going to allow us to demonstrate our angle addition property, or our angle addition postulate. We want to find the measure of angle ABC. So that's going to be my final answer, the measure of ABC. And we want to do it when DBE is complementary to EBF. Now we learned that complementary was when 2 angles add up to 90 degrees. So we know that angle DBE plus angle EBF add up to 90 degrees. Okay, so let's plug in what we know from the diagram. This angle, DBE, goes from D to B to E. So I'm going to replace that with the expression 4x plus 10 plus EBF, let me find that, EBF is replaced with the letter x. And once again, this equals 90. So now I'm just going to go and solve this algebraic expression. We've got 4x plus x is 5x. That 10 is still over here. If I want to move the 10 to the other side, I have to subtract 10. I get that 5x is 80. And I'm going to divide both sides by 5. And I'm going to get that x is 16. So that tells me angle x. So we're almost done answering our question. Our next question that we are going to actually have to answer is, what is angle ABC? So that's A, B, C. We need to know that in angle. All right, there's several ways that we can look at getting this answer. We know what x is, so we can fill in what all those other angles measured. So I'm going to fill that in. If this is x, this is 16 degrees. If this is 4x plus 10, that's 4 times 16 plus 10. And if you use your calculators, that will be 64 plus 10, or 74. You knew that too because these two angles had to add up to 90, so you could have subtracted. This angle over here, this CBD is x plus 4, so that's 16 plus 4, or 20 degrees. All right, we know also that all of these angles make a line, and so all of them will add up to make 180 degrees. So I'm going to write that down, that 20 plus 74 plus 16 plus something else, right? I'm going to give that another variable. I'm going to call it y equals 180 degrees. All right, solving this, I'm going to add up all these numbers. 20 and 74 and 16 add up to 110, plus y equals 180. Which tells me that y has to be 70. So this is the answer to my question.